Hello and welcome to another video. This time we're going to be looking at text entry on the Agon using Z80 assembler. As usual, the only tools you're going to need today are Nano for text editing and Easy80ASM for the assembler. We'll start straight away by looking at the result of what our code is going to do. So in this example, it might be, for instance, if you want to enter someone's name for a high score in a game, we're asking them to enter some text. We can see a blinking cursor and a field for them to enter their name. If I type my name and press enter, it knows what we've actually typed in. If I run the program again, and maybe I've made a mistake, and I press escape, it knows that I pressed the escape key. So how do we achieve that? Well, we've got our usual body of code that starts the program. We clear the screen to make sure everything looks neat, and then we're sending a chunk of data to the VDU. This time, what we're sending simply sets up the display. It sets a certain tab position, asks us to enter our name, it creates a background color of blue, and then prints 10 spaces. It also sets the tab position back to the beginning of that blue line. At the bottom, you can see we've got a label for answer. This is where we're going to present some text later on. We have a text buffer, which is going to store 10 bytes, each filled with 0. There is the line of spaces label, and this is going to give us 10 bytes, each containing 32. 32 being the ASCII code for a space. There's a label escaped, which is where we're going to store the text for you escaped. But here's where the interesting code starts. We need to set up a text buffer, and this is where the text that's typed in will be stored. This is pointed to by HL. We define a number of bytes that we're allowed to type in this case 10, and we define whether or not that buffer should be cleared from the last time that we used it. Moscall 9 will invoke the text editor. Once we've pressed either enter or escape, it comes back. And then we can check for ourselves what the user entered. So here we're going to compare to see if they pressed the escape key or not. And then make a decision of what to do next based on whether they hit the escape key or something else, which would normally be the carriage return. So if they hit the carriage return, the enter key, then we're going to load HL with whatever our answer is. If they hit the escape key, then we're going to load HL with an escape bit of text. Either way, we're then going to carry on to the print answer routine. Here we're going to reset the background color to black, tab to a position where we want to print our answer, and then use the usual printing routine of RST-LIL18. Finally, we've tabbed to 0,16 so that when we exit the program, it looks neat. One thing you should note from this is that when we defined a line of spaces, 10 of them, that includes the cursor. 0, 1, 2, 3, 4, 5, 6, 7, 8, and we can't type any more. So that line of 10 within our buffer includes the end of line character there. The text input Moscall could be used for all sorts of things. Here we've looked at maybe a name for a high score table, but it could be part of an adventure game or even a text editor.